Good morning, Grade 7, and welcome to WorksheetCloud, Grade 7, Natural Sciences. If you have a question during this lesson, send an email with your question to grade7@worksheetcloud.com. For those of you who don't know me yet, my name is Mrs. Hall. I look forward to teaching you this lesson today, Grade 7s, on energy efficiency. So, what are our objectives for today? We want to know what efficiency is. We want to learn how to calculate the efficiency of different items, like appliances that we use in our homes, and we want to know how to draw a Sankey diagram. So, what does the word efficient mean to you? Have you seen this picture or a similar one before? You generally see it when your mom and dad are out looking for new appliances for the home. Right, this kind of sticker comes on appliances. And I want you to look at these keywords over here. Efficiency, energy, transfer, useful, and wasted. And I want you to think about what this sticker here could possibly mean. Okay, just take a look at it. A, B, C, D, E, F, and G. Okay, just apply your knowledge. Think out of the box. What do you think it means? Okay, so this energy label indicates whether a household appliance is more or less efficient. A good rating in this respect will ensure that your refrigerator, your washing machine, or your dishwasher you buy or you cost will cost you less when you receive your electricity bills. It is therefore to inform you about the consumption of the appliance concerned. Let's take a greater look at energy efficiency. So efficiency is how good something is at changing energy into useful things. For example, we have a lamp, and what does a lamp give us? Okay, it is electrical energy that is converted into light energy, correct? However, the light energy that it gives us is very useful and it serves its purpose. But the heat energy that it gives us from the lamp is wasted and not 100% necessary. So, which lamp I'm going to show you two now would you buy, Grade 7s, and why? Okay, lamp A or lamp B? Okay, so lamp A looks like this and lamp B looks like this. And you should know by now at a Grade 7 level what the difference is between these two specific light bulbs. Right, this one over here has 80 watts. Okay, it lasts about 1,500 hours. And if you had to go purchase it in the shop, it would cost you more or less 10 Rand. This one over here, light bulb A, produces the same light as an 80 watt bulb, but it only uses 20 watts. Okay, this light bulb over here lasts about 12,000 hours and only costs more or less about 35 Rand. So which one would you buy and why? Right, light bulb A transfers more light energy than light bulb B. But light bulb B transferred more heat energy than light bulb A. So think about, what do I actually need the light bulb for? Heat energy or light energy? So a fluorescent light bulb is much more efficient than an incandescent light bulb. Okay, you learned about these light bulbs in Grade 6 in electricity. Okay. So an incandescent light bulb uses a heated wire to produce light, and most of that energy is lost as it is transferred to the surrounding air from the metal filament. In a fluorescent light bulb, less energy is lost to the surroundings and more energy is transferred to useful light energy. So obviously you would want to go for light bulb A because it transfers more useful energy than unwanted energy, wasted energy in the form of heat. Let's take a look at this little video showing the difference between an incandescent light bulb and a fluorescent light bulb. Okay, so they looked at an incandescent light bulb versus a energy efficient LED light to see which one transferred the most heat, and they used the bunny to see which one melted first, which light melted the bunny first. Interesting. So, terminology for energy flow in systems. Let's take a look. Input energy. This is the amount of energy needed for the device to operate properly. We then have useful output energy. This is the amount of useful energy produced by the device. We also have wasted energy, and this is the amount of energy that is not used for the required output. It is converted to another form of energy. So we need to remember, whenever we use an appliance or a machine, we are transferring energy from one object to another. Not all the energy is transferred where we want it. A lot of it is transferred to the surroundings, where it does not help us achieve our aims. The energy which is transferred to the surroundings is called wasted energy. Okay. So let's take a look. We have a light bulb which transfers electrical energy to light and heat. So of the 100 joules transferred, 47 joules is transferred as heat and 53 joules is transferred as light. Which transfer is useful and which is wasted? Okay, so the light is the useful energy and the heat is the wasted. So now how do we work out the bulb's efficiency? Well, the useful energy is 53 joules. The total energy transferred is 100 joules. So 53 divided by 100 equals 0.53 or 53%. Don't worry, we're going to work through quite a few examples so you'll get the hang of this. Remember, efficiency is a ratio, so there are no units to give, but it can also be written as a decimal or a percentage, so don't get confused, grade 7s. The efficiency of any device is the ratio of useful energy compared to the energy required to make the actual device do its job, its work. Efficiency can be calculated using the following equation. So we have efficiency is equal to the useful output energy measured in joules, so the whole amount of output energy that is useful, divided by the total output energy. Okay, useful output energy divided by the total output energy. And to convert this to a percentage, we simply multiply it by 100. So let's take a look at an example over here. So let's take a look at a washing machine. So we have 200 joules supplied as electrical energy to the washing machine. 100 joules of that energy is transferred as sound and light. Is that important in order to get your washing done? Does it clean your washing, the sound and the light energy? Only 100 joules is the actual useful energy that is in this washing machine. Okay, and that would be the kinetic energy, the movement of the motor as it turns the washing in the machine. So let's take the equation. Efficiency equals useful output energy. So what is the useful output energy? Okay, divided by the total output energy times 100. Okay, so the useful output energy that we used was only 100 joules, but the total energy we used was 200 joules. So let's do our equation. The efficiency would be 100, the useful energy, divided by 200, which was our total output that we put in, times 100 is 50%. So our washing machine is only 50% efficient in doing its job of washing our clothing. So let's look at the missing energy here. Can you spot the wasted energy? We have a light bulb. What is the useful energy? The electrical energy is obviously the main source of energy for the light bulb. The heat or the thermal energy is the wasted energy. In an electrical drill, okay, the electrical energy from the mains, heat is wasted, sound is wasted, and the only useful energy is the kinetic energy that turns the motor to make the drill do its job. So let's take a quick assessment. Okay, let's look at a mains operated radio. So our input energy, the amount of energy we use is 100 joules, right? That would be our electrical energy coming in. Now, if I look over here, I have two forms of wasted energy, and each form is wasted of 40 joules. So what would you consider to be wasted? I would say probably heat energy coming off the radio, as well as light. Do we need heat and light to make a radio work? No, we don't. What we do need is the useful energy, which is the sound energy. So it plays our music and gives us the sound that we can hear. Now, if 40 and 40 of it is wasted, how much of it is actually useful? Remembering our total input was 100. Okay, so the useful would only be sound energy, which is 20 joules. 80 joules through the process of heat and light is wasted. Let's look at another example. An electric piano changes what kind of energy into different kinds of energy? It changes electrical energy into sound and heat. Do we need heat from the electrical piano? No. It uses 100 joules of electrical energy to produce 20 joules of sound energy and 80 joules of heat energy. So, what is the useful energy, grade 7s, and what is the wasted energy? The useful energy is our sound, because we love listening to a piano, and the wasted energy would be the heat. Right, so efficiency, again, recap, is useful energy divided by the total energy. So here we had 20 joules of energy divided by the total, which was 100, which is equal to 0.2. Okay, or it could also be written as 20 Right, let's take a look at a thinking activity. So, what do you notice about the efficiency of each appliance that we've been looking at? What do you think has happened to the missing input energy? And can you think of a way of showing the missing energy? Right, so what we notice is that none of the appliances have 100% efficiency. What do you think happened to that missing energy? It has been transferred in a non-useful way, perhaps dissipated is the correct scientific term, as heat to the surroundings or as light or as sound. Can you think of a way of showing the missing energy? Yes, you can use a Sankey diagram. So we use a Sankey diagram to show how the energy is transferred in a system. This gives us a picture of what is happening and shows the input energy and how the output energy is made up of useful energy, the energy at the top, the arrow there, and wasted energy is the arrow going down to the bottom. Okay, look at the example. Okay, useful and wasted. So, how do we draw it? Let's take a look at a battery-operated torch. Okay, so chemical energy from the batteries. Remember, it's a battery-operated torch, so it's chemical energy converted to light energy. Okay, so we have light energy, which is 8 joules, and thermal wasted energy, which is 2 joules. Okay, so chemical energy is what's going in. That is our input energy. The light energy, yeah, can you see how thick the arrow is the useful energy. It's 8 joules. The wasted energy going downwards, the arrow pointing downwards, is just 2 joules. Okay, and that is called a Sankey diagram. Let's look at it in a little bit more detail. So, a more scientific way of drawing Sankey diagrams is to use graph paper. So you may see them like this in your exams or your class tests. So energy input from the left of the diagram, the width represents the amount of energy. And the arrow going across here is the useful energy, the output to the right. The length has no significance. You need to remember that. But here we have the wasted or unwanted energy form, and you can see it here. Okay, I hope you understand how it works on a piece of graph paper. So, useful energy is shown in one direction, and the wasted energy is shown in another direction. So we have 40 joules of chemical energy here, transferred to a Bunsen burner. 10 joules goes to sound from the burner as well as light energy, and 30 joules goes to the actual heat energy, which is the main aim of the Bunsen burner. Okay, so can you see how the Sankey diagram is working? So 1 square here on this graph, grade 7s, on this graph paper would equal 10 joules, and then you would be able to work it out. Okay. So there's your 10 joules, 1 square, and here's your 30 joules. 1, 2, 3. So energy efficiency, let's not forget, is equal to useful energy divided by total energy. It can be written as a decimal, example 0.8, or it can also be written as a percentage, example 80%. I want you to remember that nothing is ever 100% efficient. So if you do the calculation and you get a number bigger than 1.0, you have put the numbers the wrong way around. Okay, let's consolidate. So energy entering a system is called the input energy. Energy is transferred in a system to provide a useful output energy. Tools, appliances, vehicles, and machines all provide useful energy outputs. Not all of the input energy is transferred to a useful output. Some of the energy is wasted or lost. The useful output is therefore less than the input energy, as some of the output energy is wasted. Whoopsie, let's move me again. An example is a light bulb where the input is electricity and the useful output is light. However, a large amount of energy is lost to the surroundings as thermal energy. The efficiency of a system is determined by how much of the input energy is transferred to useful output energy. The greater the wasted output energy, the less efficient the system. A Sankey diagram is used to show the energy transfers in a system. In a Sankey diagram, the arrows represent the portion of the input energy which is transferred to useful energy output and the portion which is transferred to the surroundings and wasted. So just to end off, a little bit of cartoons on energy efficiency for you. I'm doing my bit for energy conservation by washing at only 30 degrees, but their clothes are not coming clean. I bought this energy saving bulb in your shop, but it doesn't work. Well, it's supposed to save energy, remember? So it's not working. And then isn't that the chap we put in charge of energy conservation? Yep, he's asleep. He's conserving his energy. Credit to Cartoon Stock for making us giggle today, grade 7s. Thank you for watching. I hope you enjoyed the lesson. I hope you have a clear understanding now of energy efficiency and you will be able to go and do your Sankey diagrams on your own when given the problems in the classroom. Have a great day, grade 7s, and I look forward to seeing you soon.